In these problems, we're going to be using a technique called implicit derivation. And if you're up to implicit derivation already, you're probably pretty good at taking derivatives of functions using the power rule, maybe using the product and the quotient rule. Probably you can take some derivatives of trigonometric functions. And you can do that just fine. All those techniques work really well for neat and tidy functions like y equals x squared. That's pretty easy. Or y equals 3 sine of 3x. You can probably take those derivatives because these functions are neat and tidy. They're already solved for y. But what happens when you get something like this? You've got x and y terms mixed up on both sides of the equation. That's where this technique of implicit derivation comes in really handy. The way it's going to work here, we're trying to find the derivative of y with respect to x. And in implicit derivation, what you do then is you just go through term by term, and if it's an x term, you're going to treat it the way you normally would, apply the power rule in this case. And all that's pretty normal. When you get to a y term, you're going to take the derivative of it as you would take the derivative of an x term, but you're going to tag on this dy by dx notation. And then we'll use that to actually solve for dy by dx. Let me show you how this works. This one starts out with a pretty complicated term, 5x times y. We're going to have to use the product rule for this one. So I'm going to take the derivative of the first thing times the second thing. The derivative of 5x is 5. The second thing is y, plus the first thing, 5x, times the derivative of the second thing. Now the derivative of y would be just 1, so since we're multiplying it by 5x, that 1 wouldn't even show up. But because we took the derivative of a y term, we're going to tag on dy dx. So that first term is done. Use the product rule. Let's go on. We have 7y to the 6th. So 6 times 7 is 42. Applying the power rule here. Y to the 5th. But since this is a y term, I have to tag on the dy by dx. Hope I don't run out of room here. On the other side of the equal sign, we're going to use the power rule here. We get 42x to the 5th. And here we have 2y. That's the derivative of that is just going to be 2, but because it's a y term, we tag on this dy dx notation. Now, what we want to do is solve for dy dx. So we're going to move all of the terms with dy dx to one side of the equation and all the other terms to the other side. So I'm going to subtract 5y from both sides. I'm going to subtract 2 dy dx from both sides. I think that's all I need to do. In this case, I will end up with 5x dy dx plus 42y to the 5th dy dx minus 2 dy dx equals 42x to the 5th minus 5y. All right, hopefully I did all that algebra right. Now, you'll notice all these terms have a factor of dy dx. I'm going to factor that out. So dy dx times 5x plus 42y to the 5th minus 2 equals 42x to the 5th minus 5y. Only one more step to solve for dy dx. I've got to divide both sides by this whole chunk right here. So this side divided by 5x plus 42y to the 5th minus 2, and this side divided by 5x plus 42y to the 5th minus 2. Here they cancel, so dy dx is this. So that's one example of implicit derivation. We're going to try another here. Okay, this problem is similar to the one we just did. There's a product on one side, and you've got x and y's mixed up. We've got some square roots here, so it's going to get a little hairy with the algebra, but we will slog our way through this. I'm going to rewrite this as 7 times the square root of x. Well, actually, I'm going to write the square root of x as x to the 1/2. Makes it easier for the power rule. And times y to the 1/2, just to show the product there. so we don't get confused. And then 6x plus 7y over here. So to start taking the derivative, we're going to apply the power rule here, and I'm going to take the first thing times the derivative of the second thing. So the first thing is 7x to the 1/2. The derivative of this second thing is 1/2 times y to the negative 1/2. And we need our dy dx on that because this was a y term we took the derivative of. So that's the first half of the product rule. Second half of the product rule says the derivative of the first thing, and that would be 1/2 times 7. So that's 7/2 x to the negative 1/2 times the second thing, y to the 1/2. And then let's do what's on the other side of the equal sign. Hopefully we won't run out of room here. So 6x, the derivative of that is just 6, and 7y, the derivative would be 7 dy dx. Okay, we've taken the derivative. Now we have to do some algebra here. I'm going to rewrite these with square roots instead of the fractional powers. So we have 7 times the square root of x times 1/2 y to the negative 1/2. So the y to the negative 1/2 would be a square root of y down here, and the 2 would go down there. So that's, dy dx. So that's this whole term. Now we have plus 7/2 x to the negative 1/2. I'm going to write that like this, 7 over 2 times the square root of x, times y to the 1/2. That's the square root of y, so I can put that up top here. That's this term. And over here we have 6 plus 7 dy dx. Okay, the next step is to get the dy dx terms on one side and all the other terms on the other side. So I'm going to subtract 7 square root of y over 2 square root of x from both sides. And I'm going to subtract 7 dy dx from both sides. All right, once we do that, we have 7 square root of x over 2 square root of y dy dx minus 7 dy dx equals 6 minus 7 square root of y over 2 square root of x. Okay, we're getting there. We can take out a factor of dy dx now. And when we do that, dy dx times 7 square root of x over 2 square root of y minus 7 there. And over here, 6 minus 7 square root of y over 2 square root of x. Now, I'm going to get some extra paper here. All right, now the next step is to divide both sides by this chunk. And let me do that on the next piece of paper. So when I do that, I'm going to get dy dx equals this chunk divided by that chunk. So 6 minus 7 square root of y over 2 square root of x over 7 square root of x over 2 square root of y minus 7. Now, that's pretty complicated, so I think we need to do a little bit of simplification with that. And let's see. I think in this case, the way I might approach it is to multiply by 2 square root of x square root of y over 2 square root of x square root of y. This is just 1 I'm multiplying, so I'm not really changing. And what will happen is that, well, the 6 will get multiplied by that, so that's 12 square root of xy minus, and here the 2's will cancel, and the square root of y times the square root of y will just turn that into a y, and the square roots of x will cancel. So this becomes just 7y. And then let's do it on the bottom. In this first term, again, the 2's will cancel, the square roots of y will cancel, and the x, square root of x times the square root of x just becomes x. So this is 7x, and then we have minus 7 times this, so that's 14 square root of x times y. And that looks pretty good. I'm not sure what else we would be able to do with this one. So I'm going to call this done. And that's our derivative of y with respect to x. So that's a little bit of work with some problems in implicit derivation. My name is Larry. I'm a teacher at EdVisions off campus. It's an online project-based school in Minnesota. If you're interested, you can find us on the web at lovethischool.org. Thanks.